Great. Welcome, everybody. Thanks for joining us today. My name is Jennifer Griffith, and I work at NUMOA, which is the Northeast Waste Management Officials Association. I have the website up here. Kate and Gail, are you able to see the NUMOA website? Oh, they're both muted. But hopefully that's showing, Kate?
Yes, it is.
Okay. So NUMOA is like I said, the Northeast Waste Management Officials Association. We're an interstate association of the solid waste programs, the hazardous waste programs, the toxic use reduction and pollution prevention type of programs in the 8 Northeast states, which are Connecticut, Maine, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island, and Vermont. But also the wayside cleanup programs work together through NUMOA, and their priority is training. So we have this series of webinars on PFAS as training for the NUMOA states, but also open to everybody to attend. And today we have 2 excellent speakers. We have Gail Carlson from Colby College, who's going to talk about PFAS Ski Wax, environmental contamination, and then also Kathryn Crawford, who's at Middlebury College, talking about human exposure aspects from ski wax. So a couple of logistical things before we start is the presentations from today will get posted on the NUMOA website. That's part of why I'm showing it. I'll show you where you can find them later. And then also, we have a lot of people joining today, so if you have questions, you should type them in. Everybody has their own GoToWebinar control box, and you should have a question section, and just type in a question. You can type them in at any point. You don't need to wait till we break for a question. We are, for this set of webinars, getting Massachusetts licensed site professional continuing education credits. So if you are joining us today and you need those, again, just for Massachusetts licensed site professionals, you have to do a few things. You have to stay on until the end of the webinar. You can't be doing other things during the webinar. So just to let everybody know, GoToWebinar can tell if you're like checking email or doing, editing a document or doing something else, reading the news, because if the webinar is not the top layer in your computer and on your screen, the GoToWebinar can tell. So if you want the Mass LSP credits, you need to keep the webinar at the top of your computer and not be doing other stuff. We did have to put some poll questions into the webinar. So if you want those Mass LSP credits, you need to answer all the questions, the poll questions, and also you do need to type in at least one regular question, in the question box. And I think that's the main thing that you have to do if you want the Massachusetts licensed site professional continuing ed credits. Those are the only credits or certificates that NUMOA can issue at this point. So just those folks. So again, a reminder that the presentations will be posted. I'll just show quick the NUMOA website. You click on events. My computer's probably a little slow because I'm at home today and don't have a camera. So like the event page is very forward focused, so it has upcoming. We have 3 more webinars after today, so you can find those here. But if you want to look at past webinars and see presentations, PDFs and stuff, you need to click on that little back arrow. That's a really key little thing to know, that back arrow, and then you get the webinars that have happened in the past. So, and then they go, whatever fits on the page here, the farthest back is at the top. So you can scroll down, and then eventually today's webinar will be the one at the bottom. These are all NUMOA events, so some of them are for solid waste program, but here's one that we just did last week. Click on that, And then you will see that the presentations are linked here, the PDFs, and then also a recording as well. So that's how you can find things. So again, type in questions at any point. And now I'm going to introduce our first presenter today, and also have her show her screen here. So our first presenter is Gail Carlson. Sorry about that. She's an assistant professor at Colby College. She teaches environmental public health in the Environmental Studies Department. Colby College is in Maine. She conducts research on environmental PFAS contamination as well as the human health impacts of climate change. She is director of Colby's Buck Lab for Climate and the Environment. So with that, welcome, Gail. And I'm going to mute myself and we'll turn off cameras, and Gail, take it away.
Great, thank you so much. I hope everybody can see this first slide. Let me know if you can't. Thank you so much for the invitation to speak. And
not your slide actually is, I don't know, am I missing something? Are other people seeing it? Maybe my computer's just slow.
I'm able to see them. I can also still see you.
There we go. Now I see it. Okay. And then you can turn your camera off. We're all set. Okay.
Perfect. Okay. Thank you. So I'm sure that many of you know a lot about PFAS and the work that I do is related to many of the different sources of PFAS, and it looks like from the NMOA website you've had lots of different webinars. And so I've been asked to talk specifically about fluorinated ski wax and how its use leads to environmental contamination. And so I'll be talking about some general information, but also some of my own research looking at that environmental contamination. And I'll allude to the fact that it's actually sometimes difficult to measure the ski wax use as say the only source of contamination, because of course where I am in central Maine, where I've done my research, there's been a lot of sludge spreading and AFFF firefighting foam use and some industrial sources. So it's a bit of a complicated story, but I will focus on fluorinated ski wax. Fluorinated ski wax is one of thousands of products on the market that, at least historically, contained very high levels of PFAS. And many of you on the call may be skiers, so you're familiar with this. Fluorinated ski wax is a product that is used for recreational skiing, but also importantly in competition. And what it does is creates a hydrophobic layer on the bottom of the ski to basically repel the melting snow and increase speed. This is one use of PFAS chemicals, per and polyfluoroalkyl substances. And PFAS are a very large family of very hydrophobic or fat-loving, water-hating chemicals that are used in many products like ski wax because they are long-lasting and they confer things like water resistance or stain resistance or grease resistance to the products that they're in. And of course, you've probably heard that includes lots of things like treated textiles and cookware and cosmetics and stain master on your carpet. But today we're talking about ski wax. So the PFAS are a set of chemicals that have very desirable chemical properties and confer high performance to the products that they're in, including ski wax. So I did a study. I was interested in looking to see if locally at the ski area that we have in Waterville called Quarry Road Trails, if you could detect environmental contamination from the competitive use of fluorinated ski waxes. And so I conducted a study with a student who actually happened to be on the Colby Nordic ski team. And we went to Quarry Road in all of our non-PFAS coated outerwear and gloves and everything, and collected snow and runoff water and groundwater right after a collegiate race that called the Colby Carnival. And the coach of the Colby team assured me that fluorinated ski waxes were being used in this race. And you can see in the map on the right, there's a couple of the brown are the trails. So that was basically the course for the day. And there were 2 sites, 1 and 2, where we collected snow on the trails. 3 was off the trail. 4 was runoff water. 5 was groundwater, and then the X was sort of a negative control for some soil that we collected in the spring after the ground thawed. And what we found is, indeed, the use of fluorinated ski waxes led to very obvious and very high levels of contamination in the environment, particularly in snow. So what we found was that after this race where the fluorinated waxes were allowed, the start line snow, we basically scraped snow from the start line that was, of course, in contact with the skiers' skis that had just been freshly waxed. There was an extraordinarily high amount of numerous PFAS in the snow that was melted and then analyzed for PFAS, over 10,000 parts per trillion, or nanograms per liter. The level was so high that the analytical lab that did the work for us actually called me and asked me what these samples were, because they were concerned because the levels were so high. We also tested snow from the ski course, but it was 3.9 kilometers into the race, and you can see that there was actually a huge reduction in the amount of PFAS in that snow, 21 parts per trillion. And so, this clearly indicates that much of the freshly applied fluorinated ski waxes were abrading onto the snow, mostly at the start line or the early parts of the race. We also looked at collected snow that was off the race course, although it was somewhat nearby, and the PFAS were reduced even more, although still detectable at 14.5 parts per trillion. And then again in the spring, we looked at the soil, both at the start line and sort of a negative control far away from any runoff and far away from the race course. And we found that the soil at the start line had a fairly significant amount of PFAS at over 10 parts per billion, or nanograms per gram. We looked at the pattern of PFAS in the snow and the soil, the pattern of specific PFAS analytes that were present, in order to assess the degree to which the ski wax was the source of, or the primary source of, contamination. So you can see on this bar chart that the PFAS complement in ski wax that was reported in the literature is the left bar, the middle bar is the snow at the start line, and the right bar is the soil. So you can see that the patterns look very similar, especially from ski wax to snow. It was basically the same complement of PFAS. And what I've learned in doing subsequent environmental testing is that there's kind of at least in Central Maine, there's a bit of a fingerprint of ski wax as a source, and it's these long chain polyfluorocarboxylic acids that are 12, 13, and 14 carbon chain length that are present in samples that I've collected that come in contact with ski wax, but are not highly present in other samples, including things like sewage sludge. And then you can see that those same 3 predominated in the soil. Subsequently, sorry, I just have to plug in my computer. Subsequently, there's been a move in the industry away from the use of PFAS in fluorinated chemicals And that action happened quite quickly, actually, and primarily because of action at the international level, specifically the Stockholm Convention on Persistent Organic Pollutants, or POPs, of which PFAS are a type of POPs. And when specific PFAS were listed under the Stockholm Convention, which is an international treaty that almost every country in the world is a party to, that aims to get rid of these persistent pollutants. Of course, the US is one of 2 countries that isn't a party to the Stockholm Convention, but nonetheless, when PFAS were added to this treaty, and especially European countries where much of the ski wax manufacturing occurs were obligated to follow this regulation on PFAS, the ski wax manufacturers shifted away from at least using long chain PFAS to start, and they really have made a pretty significant shift in that market away from fluorinated waxes. But I wanted to just highlight what the Stockholm Convention says about PFAS so far, and also show a little bit of the language of the treaty so that you can see why the international community felt obligated to act on PFAS. So the language of the Stockholm Convention includes this language: recognizing that POPs, and this would include PFAS, possess toxic properties, toxic to human health, resist degradation, they're very persistent, bioaccumulate in living organisms, and are transported across international boundaries and deposited far from their place of release, all of which is true for PFAS. Aware of health concerns, especially in developing countries, resulting from local exposure to POPs, in particular impacts upon women and through them upon future generations. And there are significant health effects associated with PFAS, which Kate will talk about. And furthermore, acknowledging that Arctic ecosystems and indigenous communities are particularly at risk because of biomagnification of POPs in the food chains, PFAS, we see that for PFAS, and contamination of traditional foods. So that was the impetus for acting on these types of chemical pollutants. The Stockholm Convention has banned or restricted a number of these chemicals. And in 2019, PFOA, which is one of the PFAS that were one of the original PFAS that were manufactured and used in very, very high volumes for many, many years. In 2019, it was listed on the Stockholm Convention for elimination. And that was really a trigger for the ski wax industry to change their formulations, the formulations of their fluorinated ski waxes. Subsequently, another PFAS, PFHXS, has been added to the elimination list. And then 2 PFAS are restricted under the Stockholm Convention. That means only very limited uses are allowed and no uses in ski wax. So you can see PFOS is the other major PFAS that has been used at very high levels for decades, is being phased out, and is a major environmental contaminant. So that was one major trigger for the shift in PFAS use in ski wax, which has important implications for environmental contamination. Importantly, the ski community, the sports community, has adopted bans on fluorinated ski wax use in competitions. And the first announcement came from the International Ski Federation, FIS, which originally aimed to ban ski waxes containing PFOA and other 8 carbon PFAS chemicals at all FIS competitions from the season 2021-2022. They ended up having to delay that a little bit because they lacked the ability to test competitors' skis quickly to see if they were violating this ban. They since have developed that technology, so the ban is in effect. And they noted, FIS noted, that the Stockholm Convention and the EU's chemicals restrictions on PFAS were the reasons for their prohibition. In addition to the International Ski Federation, US Ski and Snowboard, the New England Nordic Ski Association, NENSA, which importantly hosts a lot of youth Nordic skiing in New England, and the NCAA, so collegiate competitions have all restricted, banned the use of fluorinated ski waxes in competitions. So I've done some updated work on environmental contamination based on this shift in the ski waxes, but first I've been told to stop for a poll question.
Okay, can you hear me now?
Yes.
Okay, I'm going to launch the question, which is, which PFAS predominate in environmental samples contaminated from fluorinated ski wax use? Short chains, the 4 to 6 carbon PFAS, medium chains, or long chains? So please vote. You just use your cursor and click on your choice. We'll just let a few more people vote. If you want the Massachusetts Licensed Site Professional credits, you need to answer, and everybody else is just encouraged to answer because it's kind of fun. So let's just see how people vote here, and then, okay, looks like that's a good amount. I'm going to close the poll, and then I think I can show the results here. Oops. Share. Okay, here's how people answered. Gail, I'm not sure if you can see that, but 6% said short chain, 16% said medium, and 78% said long chain. Which is the correct answer, please?
The correct answer is the very long chain PFAS, at least in my research.
Right, or what was found in those samples that you collected from the environment. Okay. That, oops, oh my gosh, yikes, no, oh my gosh, I almost clicked the wrong thing, I guess. Okay, I think I closed that and you can carry on now. Thank you.
Yes, hopefully if you can still see my slides.
Yes, I can totally see your slides. Thank you.
So I continued this work with another student where we went back to the same ski area 2 years later when they were having the Colby Carnival race again. And at that race, the Colby Nordic ski coach assured me that there was a ban on fluorinated ski wax use in collegiate competitions, and therefore they would not be used in that same race 2 years later. So we did the same thing where we collected snow at the start line and later in the course and off the course. And this time we also collected some artificial snow that had just been made and was in a pile. And the snow was melted and analyzed for PFAS. And what we found, this graph shows, again, the ski wax pattern, the snow from 2020, and then the snow from 2022. First of all, we found that there was about 400 times less PFAS in the snow right at the start line at this race compared with the race when fluoro waxes were used. So that is already a significant measure of reduction, important reduction in environmental contamination in the snow. You can see that the pattern of the PFAS that were present in the snow in 2022 was fairly similar to the snow in 2020. So it still has that fingerprint of ski wax as a source, including those same 3 very long chain 12, 13, 14 carbon perfluorocarboxylic acids, present in that newer snow sample. So there was still something happening in that snow. It was either that maybe there were a few competitors who were cheating, or maybe some recreational skiers had gone who had fluoro waxes on their skis had gone through the area. But of course, importantly, a lot less contamination. So this has important implications for the overall contamination at this site. This graph, this bar chart actually shows the different snow samples that we collected in 2022, and shows some important things about the sources of PFAS. So the start line snow, these are different colors, but anyway, the start line snow is the left bar, and then the snow that was collected off course looks completely different. It only had one PFAS in it, happened to be just PFOA, so only one. It looks very different. And then the artificial snow looks different as well. So all three of those snow samples look different. Interestingly, not surprisingly, the artificial snow at this particular place is made with stream water, and it's called the Messalonsky stream, and it's pumped from the boat launch, which you can see in this photograph, up, and then is frozen and blown in a big pile. And you can see that actually the stream PFAS contamination pattern, the three most prominent PFAS in that sample are the three most prominent PFAS in the artificial snow. Also, and the stream is contaminated because it runs south from north to south through the city of Waterville, but right before it passes through the Quarry Road Trails area, it meets up with a stream that is running off from Fairfield, Maine, where there was a significant amount of PFAS-laden sludge spreading on land, including on farms at very high levels, some of the highest contamination in the state of Maine. And those PFAS are in the soil and are running off in surface waters, and that surface water from Fairfield runs into Messalonsky stream. And so there's significant contamination in the stream, on the order of, 100 or more parts per trillion. And what's happening is when artificial snow is being made at the ski area, it's basically a net movement of PFAS from the stream running through back up onto the land, because when that artificial snow, which is spread all over the trails, melts, of course, the PFAS, are either run off or are deposited in the soil underneath. Interestingly, we had seen groundwater contamination at this same site. It's very shallow groundwater, and the contamination there looks more like the stream contamination, which is again coming from runoff from the sludge-spread fields, than it does look like contamination from ski wax use. Numerous sources are contributing to environmental contamination. Other places that have documented some environmental contamination from ski wax use have reported that their groundwater aquifers are contaminated with PFAS that they think are coming from ski wax. One example is in Park City, Utah. This was a recent headline, and they looked at their groundwater, and they did some sampling of ski wax and found that the patterns looked somewhat similar. So they're claiming that their groundwater is actually contaminated with from ski wax use. Interestingly, in this particular study, their snow samples, they looked at snow and groundwater, their snow samples were predominantly short chain PFAS, not long chain like what I found. But I will say that the formulation of ski wax has changed a lot since the PFOA ban, and it may be that some of the ski waxes that were residues that were detected in my study were still the older ones with longer chain PFAS, and perhaps some of the newer contamination is coming from these newer ski waxes that may be enriched for shorter chain PFAS. So it definitely complicates the story. So the other thing that I just wanted to mention, there are some PFAS regulations in the state of Maine that directly affect the use of fluorinated ski waxes and other PFAS sources. So I wanted to just mention them very quickly, and this is just a couple of the many regulations that Maine has enacted. Maine is really a leader among US states in responding to the PFAS crisis. So in 2021, they passed a first in the world ban on non-essential uses of PFAS in products sold in Maine, and that was to take effect by 2030, and they updated it, which I'll explain in a minute. In 2022, they banned land spreading of waste biosolids, which of course is the such a major problem here in central Maine and the source of contamination of the stream that's running through the ski area. And in just this past legislative session, they amended that first in the world ban on PFAS in products to include a ban on specifically named products and on a much faster time frame. So this includes a ban on PFAS in ski wax and in things like textiles, cookware, cleaning products, cosmetics, menstrual products, dental floss, products for children, and effective just over a year from now, January 1st, 2026. So that's good news in terms of minimizing the environmental and health impacts of PFAS in a lot of these products, but we're talking about ski wax here today. And, a couple other states are following Maine's lead, and, I'm sure there will be more and more of these product bans coming soon. So kind of the elephant in the room as we think about this extraordinarily quick, near elimination of PFAS in one particular product, namely ski waxes, where are all the unused fluorinated ski waxes going? And of course, this has enormous waste management issues. And those of you on the call, you know better than I do where a lot of the PFAS in your waste streams are coming from. Of course, it's not just ski waxes, but there have been some fluorinated ski wax take back events and programs in the state of Maine, and a lot of that wax that's been collected has actually been landfilled. We also have had, with the sludge spreading ban, some wastewater treatment plant biosolids have been landfilled, and this is a major problem. So this is the PFAS in product. The products containing PFAS don't go away. We have to deal with them. Also, the PFAS themselves are very, very persistent. Many of them are very persistent in the environment, so we still have to deal with environmental monitoring, and we still have to deal with the fact that the PFAS in these ski waxes that are being discarded are going to persist, are going to interconvert chemically into other PFAS, and we're still a long way off in terms of developing ways to destroy these PFAS, so that we can deal with all of the mitigation that has to happen. I just wanted to mention that there are some fluorinated ski wax buyback or take back, programs ongoing and that are currently not landfilling these waxes. And one of them is being carried out by a company called Mountain Flow Eco Wax, which happens to have been started by a Colby graduate from the class of 2007. His name is Peter Arline, and Mountain Flow Eco Wax was one of the first companies and an American company that made plant-based ski waxes, so was abandoning the fluorinated hydrocarbon wax technology. They have a program where you can actually send them your old ski waxes, and they're warehousing them until, as they say, the EPA gives guidance for how to safely destroy fluorinated ski waxes. So again, you probably have more answers than I do to that question of how to deal with waste management with respect to fluorinated ski waxes, but it's obviously going to be something we're going to be dealing with for a long time. And I will stop there.
Great, thank you, Gail. There's quite a few questions. Oh, you might want to still show your slides because you might want to go back to them with some of these questions. But so that was great. There are quite a few questions. So someone wants to know, I'll just sort of go in the order that they came in. Whether Clister and kick waxes also have fluorinated PFAS? Have they traditionally been fluorinated?
Yeah, I mean, definitely, yeah. And Kate can actually also speak to this, but all of the different types of fluorinated waxes that have been used are all being phased out, and non-fluoro alternatives are being used. But yeah, I believe, and Kate, correct me if I'm wrong, but I believe the Clister was contained, was fluorinated, and do you have any? Oh, go ahead, Kate. Go ahead.
No, I was just going to say that is correct. There were in fact fluorinated kick waxes, both Clister and the harder forms of kick wax as well. And I think, yeah, I can get more into that when I do my section of the talk. I will just maybe briefly add into the conversation that because those are used under more limited circumstances and kind of lower volumes, I think, and Gail, hop in if this is not correct in your understanding or your research, but my sense is that the concern over the contribution that those kick waxes have made to overall kind of environmental contamination from ski waxes is just a lower concern.
Yeah, and in terms of the Colby Carnival race, I was assured that none of those fluorinated waxes were allowed to be used. So we weren't actually, we didn't have that resolution where we were trying to understand which waxes. Many, competitive teams, many recreational skiers have boxes of, ski wax, and, the extent to which they're still being used under certain circumstances, of course, is unknown and probably varies. But certainly any newer waxes that are out on the market now, are in the kind of mostly post-fluoro wax era. And, you can read the labels now and see what, well, you could before too, but, things like the old waxes would say like, HF for high fluoro or LF for low fluoro or, whatever. So.
Right. Or I have some, I forget what it's called, the stuff you put on when the snow is very new, and it's like F4, so, or 4F or something. So let's see. Another question is, if you could talk a little bit more. So the international ban, when you put the language up, it really was talking about C8 and PFOA, but it's since evolved to incorporate all PFAS, and do people really understand that? And is there a difference between what's restricted and banned here in the U.S. versus, internationally, or are there different standards in different places, or what's happening?
Yeah, so that's an excellent question, and I keep deferring a little bit to Kate because correct me if I'm wrong, Kate, but I believe your spouse is a ski coach. I am the parent of the young man in the picture here, so I was a Nordic skiing parent, but not a coach myself. And of course, my son was the one member of his team that was not in the wax shed and was coming home and using hydrocarbon waxes on his skis. The initial impetus for changing formulations of ski waxes was the PFOA restriction under the Stockholm Convention, because PFOA and other C8 carbon chain PFAS were being used as sources, and also they knew that they were enriched in these ski wax formulations. And it was not always easy to figure out all the companies were not necessarily talking about the specific chemicals or the specific manufacturing steps. So it wasn't always clear exactly which PFAS were in, which waxes, which is why, that paper that I quoted from 2015 was very helpful, because somebody actually did test, the wax to see what was, at least older waxes, to see what was in them. But now, so initially the language was that some of these manufacturers were going to move to shorter chain PFAS in production of their waxes. But these companies also, have entirely fluoro-free waxes. And I think that's really where the change has to happen, because in competition, you can't use fluoro waxes anymore. And, competitors like FIS competitors in, you know, international competitions are actually having to submit their skis to this little kind of handheld device that you put up against the bottom of the ski, and it can actually detect whether or not there's fluorine residues on the ski. And there was I think the first case was might have been a Norwegian woman who was disqualified in a race, although she claimed that she didn't know where the fluorinated wax residue would have come from. You know, so I think the protections, the regulations may differ, because of course the European Union is doing much more to restrict PFAS than the United States government is doing, although we are at the federal level taking steps to start regulating PFAS, but we have a very different chemicals regulation than the EU does. But the industry is kind of moving, you know, kind of uniformly, so it's affecting, you know, European skiers or Asian skiers or American skiers in similar ways. Also, US Ski and Snowboard has also banned it, and, you know, NENSA and collegiate racing, Eastern Cup races, those kinds of things. So, you know, so I think it's a little bit more of a uniform, you know, sort of response, if not regulatory landscape, in terms of the use of these waxes across different, you know, different jurisdictions. I hope that answers the question.
Yes, I think so. There's also some concern about, you know, instead of measuring just the individual PFAS compounds, of which I think we can do 40 or 50 now, you know, did you do total fluorine analysis or any sort of totals to know whether, or the, you know, top assay or something about the precursors and the things that you don't necessarily see when you do targeted analysis?
Yeah, that's a great question. And no, we didn't. I wasn't doing this in my own laboratory. I don't actually have a chemical laboratory, so we were using the company Alpha Analytical, and they had in 2020 a 24 PFAS panel, and starting in 2022 they had a 28 PFAS panel, the standard one, and I know the Maine Department of Environmental Protection was using them as well. I did present the numbers for total PFAS, but only in that, you know, in that panel. So,
right.
You know, it's very clear that if those waxes are used, they are, and you know, there are other studies, they are rubbing off onto the snow, and then you know, many of them are quite persistent. The shorter chain PFAS are more likely to run off in snowmelt, get into surface water, groundwater, perhaps soil. The longer chain ones are less likely to move and more likely to deposit in the underlying soil under the snow. So it is, you know, my interest was really just to kind of try to characterize, you know, whether or not that was happening, which, you know, clearly it was.
Yeah, right. And because they are so persistent, even though they've stopped now, which is a good thing, there's still all this historic deposition that's happened. So, all right, well, I think in the interest of time, there's definitely a good question for both of you here that I will ask at the end, and, you know, and some more concern about, yeah, there's more we'll talk about at the end, I guess. So in the interest of time, I'm going to introduce our next presenter and also make her the presenter here to show her screen. So let's see, did that come across? Okay, so our next presenter is Kathryn Crawford. She's an environmental health scientist and assistant professor of environmental studies at Middlebury College. Her research seeks to bridge the gap between environmental science and human health and includes several PFAS-related research projects, which draw on exposure science, epidemiology, and risk assessment methods. So one project, in collaboration with Boston University School of Public Health, she's focused on people's PFAS exposure from ski and snowboard waxes. So, and she's an avid skier herself. And she also studies the impacts of PFAS exposure during the perinatal period on maternal health and child health, as well as seafood consumption as a source of source of PFAS exposure. So she's got a lot of good experience. If people are interested in those topics, they could contact Gail offline here. Now, before she starts, though, I have to do a poll question. So I'm going to launch that. Where does Kate work? Just mention that. Colby College, University of Vermont, Middlebury College, or Boston University. Please choose. And we'll just do this just because I got to do poll questions for these Massachusetts licensed site professionals. So this is just a sort of a silly one to make sure people are paying attention. And let's just leave it open for another 10 seconds or so. You can vote. And okay, I'm going to close it. I don't think I'm going to bother to show it. Basically, Kate works at Middlebury. So with that, I'm going to mute myself and take it away, Kate.
Wonderful. Can everyone see my slides, Gail or Jennifer?
Yes, I can see your slides, and yeah, you turn your camera off, and yeah, there we go. Now they're big. Good.
Here we go. All right. So thank you all for being on this call today, and thank you to NMOA for the invitation to share some of our exciting new work with you today. I hope that you find it as interesting as Gail's talk was. Gail, thank you so much for the introduction to many of these topics. I feel like I should bring you on the road with me anywhere I go when I talk about this project, because that was a really fabulous overview of some of the environmental impacts and especially the regulatory landscape as well. So thank you for that. So as kind of was alluded in that introduction, my expertise is really in the kind of environmental health and human health realm. And so that's where I'll be focusing today, both as a reflection of some of the new work that we've been doing and also as a complement to some of the work that Gail's been doing, really looking at PFAS from ski and snowboard waxes, which I will collectively refer to as skiing in this talk, in environmental samples. So as Gail alluded to, right, we're applying these waxes to the bottoms of skis and snowboards or skis because people are looking to go faster. And when we're thinking about health, one of the elements that we think about health in the context of skiing and snowboarding is potentially mental health, right? It's often something that people are doing because they're enjoying being outside, it's for fun, it's recreation, it's a hobby. And so in that context, having the most enjoyable experience possible is a good thing, and going more quickly is typically part of that for people, or potentially applying these waxes to the base of your skis to make the ski perform better in a certain snow condition, right? Like ideally that is a good thing. However, as we have been talking about, and as you know, because you're on this call, the presence of these PFAS compounds in some of the fluorinated ski wax products has had a lot of deleterious consequences as well. And so just briefly, I'm going to set the stage for the human exposure side of the equation by way of giving an overview of how ski and snowboard waxes are applied, because I'm guessing that some people on this call are familiar, but likely not everybody is. So here's a picture of a type of fluorinated ski wax, and as Gail alluded to, and we'll see in a few slides, there are a whole lot of fluorinated wax products that have been on the market historically, and so this is just one example of many. They typically come in a variety of forms. We talked a little bit about the kick waxes, and those are waxes that are put onto the base of cross-country skis to help the ski stick to the snow so that you can do the kind of the quintessential type of classic skiing or cross-country skiing that you see with people kind of using a sliding forward walking motion. And then there are also a lot of glide waxes that are applied to cross-country skis as well, but also skis and snowboards that are designed to help the ski just slide better across the snow surface. And those ones come in powdered liquids and solid forms. So this is a picture of a powdered wax. Typically, those waxes are then applied to the base of the ski or snowboard by way of heating it into the base of the ski somehow. In this particular picture, you're looking at someone ironing a solid form of a fluorinated wax, or a wax period, into the base of a ski. You then scrape off any excess wax that gets onto the base of the ski. You almost invariably apply a little bit more, or potentially a lot more than you need for optimal performance. So then you remove that excess. And then the last step is kind of a brushing or usually a brushing process or a wiping process that gets any of the final excess off. And what you're left with is this nicely waxed ski surface, right? One that repels water very nicely and slides across the snow surface kind of as quickly as possible. So inside a wax room looks something like this, and we're talking about wax rooms where this is kind of a wax room where people are probably waxing for competitive purposes, but even a recreational wax room probably has a lot going on, again, reflecting the fact that there are many types of wax products that are used. There are a lot of tools that are also used to apply those waxes, and then there are things like solvents that might be used to remove the wax products at the end of the day. So there's a lot of potential types of environmental exposures that could come from the ski and snowboard waxing process. We're obviously focused on the chemical exposures coming from these fluorinated waxes, but particulate matter is also a concern. These solvent exposures might also be a concern as well. So as I mentioned, there are a lot of different types of ski wax products, and as Gail alluded to, some studies in the past have tried to document the types of PFAS that are found in these wax products as a way to both predict what types of environmental contamination we might expect to see, but also from the perspective of what types of things humans working in these spaces or waxing their skis might be exposed to. This is a study from 2020 that purchased a series of waxes in Norway in 2019 again. So this was theoretically before any of those kind of PFAS or fluorinated wax restrictions went into effect that Gail was referring to. And so on the y-axis here, we have a range of the different types of waxes that they purchased in the study. And on the x-axis, we have concentration in nanograms per gram reported for all of these different waxes. And a couple of big takeaways here. One is that there's a high variability in PFAS content between the different wax products, and also for the ones that contain the most PFAS, we're talking about concentrations that really range up to hundreds of parts per million. So these, and this is just from the targeted analyses alone. So these are really high concentrations, and we know from looking at the SDSs of these waxes that the PFAS in them can contain up to 70 to 100% by mass. So these are really quite potent products when we're thinking about the PFAS landscape. When we look at the panel on the right here, we see that PFOA is one of the compounds that they looked at specifically to represent this reality that long chain PFCAs are one of the kind of predominant classes of PFAS that we see from these targeted analyses. I'm not going to get into it today, but I do just want to refer to the question that Gail was answering right at the end of her Q&A section about non-targeted analyses. There are a handful of studies that have started to try to compare different approaches of non-targeted analyses in ski waxes and environmental media around ski and snowboard venues to try to look at this exact question of how much are we actually able to measure from these targeted analyses, what other potential PFAS compounds and or categories of PFAS might be present in these products. So that work is underway. I won't dive into it today specifically, but I just wanted to acknowledge that question. This is another study that basically was looking at a similar type of thing, but using some wax products, again, purchased before when you would have expected those bans to go into effect, and some that were purchased after. So in this particular case, the first two bars are wax products that were purchased in Austria in 2022, so theoretically after the PFOA ban and the introduction of some of these restrictions on ski waxes were going into effect. The other bars represent waxes that were purchased before then. And again, the major takeaways here are one, that there's high variability in the PFAS profile between these wax products, and also that these are really, again, dominated by these long chain PFCAs. Another thing to note is that it's really hard to know manufacture dates for these products. We rarely know that. So one, just thinking about this globally, not necessarily specifically in the context of the study, but globally, one that we know that there are these wax products still floating around out there, either in people's personal collections or potentially on shelves, although I think at this point it's actually getting relatively difficult to purchase fluorinated waxes in the US. That has largely to do with, as Gail was referring to, the restrictions on kind of the production of them. Most of these wax companies are in Europe, and so they are closely following EU REACH policies that they're kind of governed by in that context. And also because there have been some incidents with import penalties on US ski and snowboard companies bringing these wax products into the US. And so at this point, that has been a costly process to some of those companies, and they are not incentivized in any way, shape, or form to try to cheat that system. And so it is actually getting quite difficult, I think, to really purchase fluorinated waxes, although there may be some shops out there that have kind of old stock on their inventory that they're still selling, but it's not the predominant, fluorinated waxes are not the predominant waxes being sold at this point in time. So as Gail just mentioned, and I'm not going to go through this in detail, but I just wanted to briefly summarize, right? We know that there are PFAS being released into the environment from the use of waxes. This is because there are detections in environmental media near ski and snowboard venues. As Gail's research documented, right, that's highest at the start and then a braiding off of the snow surface as people glide across the snow. So there's geographic distribution or geographic variability even within a single ski venue. And again, even in these environmental samples, we see these long chain carboxylic acids really dominating the PFAS profile. There's also been this bioaccumulation documented around in wildlife near ski venues. So again, there's this environmental impacts, I guess I should say, both on the environmental media as well as the biological life in that area as well. And so then extending that to think about, okay, what about the biological life in areas where people are applying these ski and snowboard waxes? And this then brings us into the human exposure and health impacts realm that I'll be focusing my talk on today. So there's been really limited research so far to understand PFAS exposure from ski and snowboard waxes. There were a few studies done kind of in the late 2000s where they were looking at professional ski wax technicians to try to understand what people were being exposed to again. And this is now, 15 years ago or so. These documented really high exposure levels and acute health impacts from these fluorinated wax exposures. And if we specifically look at the concentration of PFAS in these workers, these professional wax technician workers, we see that, so the professional wax technicians are the middle series of bars. The general population is on the left, and they're being compared to workers that are working at a fluorochemical manufacturing facility, 3M workers on the right. And what we see is that PFOA, which is that dark bar in the middle, is much higher in the ski wax technicians than in the general population. And while it was a really small pilot study, so the error bars on these estimates are quite large, the upper end of that concentration range is within the range of what we would expect to see or what has been reported at some of these fluorochemical working or fluorochemical manufacturing facilities. And so this is potentially painting the picture of some really high exposure levels within the ski and snowboard community. However, as we'll get to when I get to kind of describing the motivation for our work, the professional wax technician of 15 years ago is a very specific type of person that's skiing and snowboarding, right? These are people that are waxing skis, for the full-time job and at a very, very high level of competition. And that really doesn't reflect the average person that's skiing and snowboarding. So what do we know about the adverse health impacts of PFAS? We know a lot. A lot has been invested from a research perspective into these questions over the last few decades. Of course, there's a whole lot more that we also don't know, but this review article from a few years ago now did a really nice job summarizing kind of what we do know. So as you can see here, there's a range of adverse health outcomes that have in at least some studies been documented to be associated with PFAS exposure. The solid line, so things like thyroid disease, increased cholesterol levels, liver and kidney impacts, testicular cancer, and then some pregnancy-related health outcomes are the health outcomes for which we have the most kind of complete or compelling data to support the associations between PFAS exposure and these health effects for at the moment. The dashed lines are ones that are more suspected or have been shown either inconsistently or in fewer studies and are kind of more active areas of research. But the point being that there are a number of adverse health impacts that are quite likely associated with PFAS exposure, right? We have a lot of data supporting these associations at this particular point in time. So given that, we a couple of years ago were interested in taking a first stab as like, okay, who are these average skiers and snowboards? What are they doing with respect to wax use? What do we need to focus our future research efforts on? So we asked about 500, almost 600 participants via an anonymous web survey who are skiers and snowboarders within the US, what types of waxes they're using and if they're waxing at all. And so this first bar on the top of this figure shows the blue are the people who responded yes, the yellows are people who responded no. And what we see is that first bar is did people wax their skis? And most people reported that they had in fact applied waxes of any type at least once. Most people, the next bar down, reported using non-fluorinated waxes, but still, so that third bar down, still 67% of people reported that they had used fluorinated waxes at least one time. And again, there's a whole lot of different products, so this isn't entirely surprising for people who are skiing and snowboarding. And when we asked about those people who reported fluorinated waxes, right, we see a range of different types of wax products that they're using, low fluoro, high fluoro, and these pure fluoro wax products, which are the most fluorinated. So again, the key takeaway here is that most skiers and snowboarders are in fact using waxes of some type, and many of them were regularly applying fluorinated waxes. When we asked about people's kind of exposure interventions, we see a very opposite profile. So again, on the y-axis here, we have a range of different types of exposure interventions, respirator use, masks, working in a well-ventilated area, etc. And we see much more yellow. That's the main takeaway, right? Fewer people are using these exposure interventions than are applying these fluorinated waxes. So we recognize here that there's kind of a mismatch between the use and the people taking steps to prevent their exposure. So all of this work collectively leads to the current study that I'm about to share with you. So one, we wanted to quantify PFAS concentrations in active skiers in the US, so in the blood of people skiing in the US. And then we wanted to look at associations between serum PFAS concentrations and various health biomarkers, as well as self-reported symptoms that people experience during waxing and other self-reported health conditions. So in order to do this, in the summer of 2023, we recruited 30 adult skiers with a known fluorinated wax exposure history. All of these people had said that they had used fluorinated waxes at least once, and they had to have been at least 18 years of age. These people provided written informed consent, and then they both answered a questionnaire that had questions about their waxing history, their exposure reduction use, their health history, other sociodemographic characteristics, and not mentioned here specifically, but also other potential PFAS sources of PFAS exposure. They also provided a blood draw, and the serum from this blood draw was analyzed for 18 targeted PFAS compounds at the New Jersey Department of Health laboratory, and we also measured health biomarkers for lipid, thyroid, and immune health, which was analyzed via the Boston Children's Hospital Environmental Medicine, Clinical Medicine Department. So within this pilot study, again, small pilot study, 30 participants, we had the median age was 21 years old. People ranged from 19 to 64 years of age with a pretty healthy BMI. Roughly half of the participants were men and women, and I should note that no one reported any other gender identity besides men or women. This population was relatively well educated. The participants who reported only having some college tended to be the younger participants in this study. And then we asked them again about their wax use. And so before the ban, people reported on average, or in the median number of skis that they were waxing per year, of 30 pairs of skis per year. And after the ban, they were waxing slightly more skis, 44 skis per year. 37% of people in our study reported being a current coach. And then most of these people actually were using some sort of exposure intervention. So here are the concentrations that we saw in people's serum. Here we're only reporting the 10 compounds of those 18 that were analyzed that were detected in at least 60% of the samples. And I'll be focusing on these for the rest of this talk. A couple of things to note here are that we have the individual PFAS compounds along the x-axis and concentrations reported in nanograms per milliliter on the y-axis. This is broken out by people who were reported being coaches, which are in yellow, and non-coaches being in blue. And the column on the far right is the NASEM sum. This is calculated as the simple additive sum of these compounds listed here in accordance with the National Academies of Sciences, Engineering, and Medicine. And a couple of things to note are that we saw PFDA, PFNA, PFOA, and the NASEM sum were positively associated with ski waxing intensity after adjusting for age and gender identity. These compounds, as with most of them, were also higher in the coaches as opposed to the non-coaches when just looking at the raw numbers as well. And One interesting thing is that PFNA and PFDA were the two compounds that were most enriched within the coaches relative to the non-coaches. So we were interested then in putting this into the context of what has been seen or reported in other studies looking at serum concentrations of PFAS. So here we're comparing a range of different studies. Give me a second to walk through this figure. I know there's a lot going on. So we're looking at different studies on the y-axis with NHANES, or the National Health and Nutrition Examination Survey, which was representative of the general US population in the top bar. Then the next series of bars highlighted here in red, or next rows rather, highlighted here in red are our study. So the first row here is our study overall, and then broken out by coaches in the next row down and non-coaches in the row below that. Then looking at those compared to other ski studies that have been previously reported, studies in firefighters, studies in communities exposed to contaminated drinking water, and again, fluorochemical workers as well. And a couple of big takeaways here are that when you look at, so again, we're looking here, I'm gonna see if I can you all see my cursor at the moment? Hopefully.
Yeah, you can.
Okay.
The little dot.
Yep,
the little red dot.
Okay, great. So again, we have NHANES here in this top row, and then we have our study overall, and then these other ski studies. So a major takeaway is that when we look overall within our study, and I should have mentioned that we picked these 4 PFAS compounds because they are both highest concentrations in our study, but also ones that tend to be most commonly reported in the literature, so that we would have other points of comparison to look at. So for example, for PFOA, if you just look at our study relative to NHANES, you can see that our study actually has lower concentrations overall for PFOA than in NHANES. But if you look specifically at the coaches, this story is a little bit different, right? They have higher concentrations. I should have mentioned that the dots are the median concentrations, and then the bars represent the minimum and maximum, or in the case of, for example, NHANES, just the 95th percentile. This story of the coaches having kind of higher exposure levels in the general US population plays out across these different compounds, with non-coaches having concentrations that are either relatively similar to or slightly lower than the general US population. Our concentrations are quite a bit lower though than what was reported in these previous studies of ski wax technicians. And again, that's not surprising given that this is a really specific kind of an unusual group of people who are waxing skis compared to the people that we were surveying, and also that a lot has been learned about the need to use exposure reduction since then, and also these changes in wax formulations. And interestingly, the concentrations that we see in our coaches across the board, and especially for PFNA and PFDA, are higher than what has been reported for example, even these firefighting cohorts, where again, we have a population of people that is understood at this point in time, or has been documented to be more highly exposed than the general population. So that gives us, again, a little bit of a sense that we do have some exposure. It tends to be highest among these coaches, but again, it does seem to be a concern within this population. So again, we took these concentrations of the various PFAS in serum, and we again used this process of like, okay, what are we trying to answer about health outcomes, right? We're trying to figure out if there are any associations between these exposure levels and these health outcomes that we were interested in. So we used multivariable linear regression to estimate these associations, and all of our models were adjusted for age and gender identity. And here I'm just showing you the concentrations for 3 different cholesterol fractions: total cholesterol, low density lipoprotein cholesterol or LDL cholesterol, and small dense LDL cholesterol. And what we see here, oops, advance my slides here, is that we saw positive associations between PFAS concentrations and all of the different PFAS that we were looking at, including the NASEM sum for these various PFAS for each of these cholesterol fractions. We also, oops, here we go, saw this with the self-reported cholesterol, which we'll get to in a second. We did also see imprecise, although kind of consistently positively associated relationships between the PFAS concentrations and thyroid stimulating hormone. But again, these were imprecise and less kind of consistent. And the same was true with immunoglobulins, which were the markers of immune function that we had also looked at. So just backing up for a second, the way that you would interpret this figure, for example, is that for every interquartile range increase, so an interquartile range increase of the nascent sum of PFAS would be about 6.33 nanograms per milliliter of this nascent sum of PFAS. You end up seeing, for example, a 32.1 milligram per deciliter increase in total cholesterol, a 35 milligram per deciliter increase in LDL cholesterol, et cetera. And so again, this kind of paints the picture that you do in fact see these increases in cholesterol, these specific cholesterol fractions with increases in PFAS concentrations in people's serum, even in these very active skiers and snowboarders that we were evaluating. So again, I mentioned that we asked people about other health conditions that they experienced. And in this particular case, I'm showing you a figure of symptoms that people commonly report experiencing during waxing. So cough, dry nasal passage, skin and eye irritation, again, reflecting the exposure routes that you might be thinking about when thinking about potential inhalation exposure or contact with the PFAS wax itself or PFAS in the airborne fraction near these ski waxing areas. And we see that most people in this study had reported experiencing these symptoms while waxing. Similarly, and again, we have percent across this x-axis here, so we can see up to 60 some odd % of people are reporting experiencing those symptoms while waxing. We also asked about some diagnoses, phrasing the question of have you ever been diagnosed with X? And these are showing the conditions rather that at least 5 people in our study reported having experienced before. And we see that high cholesterol, some reproductive related outcomes, menstrual cycle irregularity, et cetera, and also some immune system allergies, specifically in asthma outcomes are amongst the symptoms that are most commonly reported. And that's not necessarily surprising given the just general population, but it did speak to why we chose to select the specific health biomarkers that we looked at. So here we have the associations, as I was mentioning before, using a multivariable regression modeling technique, in this particular case, logistic regression, looking at relationships or associations between these PFAS concentrations here and cough in this particular case and high cholesterol here. So again, these were people reporting that they'd experienced a cough or reporting that they'd been diagnosed by a medical provider with high cholesterol. And a couple of big takeaways is that in this particular case here, let's just look at high cholesterol for a second, since that's what I focused on before. We again see these kind of positive associations, regardless of which particular PFAS compound we're looking at, these positive associations between self-reported high cholesterol and these PFAS exposure levels, again, after adjusting for age and gender identity. So I'm going to take a moment to pause here and ask my poll question, and then we'll move on to another part of this study in a moment. Okay, are you ready for me to move on, Jennifer?